Welcome back. We are now going to fix the critical bug in our ticket booking use case. The negative ticket count was caused by both threads entering the critical section simultaneously. We will now integrate the lock object to ensure that only one thread can check and modify the available tickets variable at a time. 1. Initializing the lock. Just as available tickets is a shared resource, the ticket lock must also be created once and shared among all threads that need to access that resource. We create one instance of threading.lock parenthesis at the global level, and this single lock instance will now be used by both of our competing threads. 2. Protecting the critical section. We insert ticketLock.acquire parenthesis at the entry of the critical section. Now, when user 1 calls this, it acquires the lock and proceeds. When user 2 calls it immediately afterward, it finds the lock held and is forced to wait indefinitely at this line until the lock is released. This enforces mutual exclusion. We ensure ticketLock.release parenthesis is called an finally block to prevent a deadlock if an error occurs within the protected code. 3. Verifying the fixed logic. When you run the synchronized code, you will observe the output confirming that one thread acquires the lock first. The other thread is seen waiting. The first thread successfully books the ticket and decrements the count to 0. When the second thread finally acquires the lock, it finds that available tickets is no longer greater than 0, and it is correctly denied the ticket. The final ticket count is consistently 0, confirming that our race condition has been successfully fixed. To summarize, locks are the foundation of safe multithreading. Our next lecture, 26.12, Synchronization using lock. See you there.